This video addresses two different problems from, I believe, the 4.2 WebAssign homework, and it's problem 6 and problem 8. So for problem 6, you're given a ramp, and you're given dimensions on the ramp. Obviously, I did not draw them to scale. And you're given some guidance on how to find the angle. I actually calculated it here. Then you're also given data for the distance and the time at which the ball rolling down the ramps hits those different distances. You're asked to then graph x versus time squared and create that graph. Now, this would be on your y-axis and this would be on your x-axis. I inputted this into the statistics function in my calculator, and then because I'm using t-squared, I can use a linear regression. They called it the linear least square fit or something in the question. So when you do that, it spits out this as the equation. However, you have to remember that x is 1/2 at squared. So that means that this 0.133 meters per second squared is 1/2 of a. So to find the acceleration a, it's 0.226 meters per second squared. And then you're asked to compare it by using the theoretical acceleration a equals g sine theta. So then I just plugged in here and I found that as well. So that would be how you do problem number 6. For problem number 8, here we have a box on the bed of a truck that is going up a hill, and if the truck accelerates at a rate of 2.4 meters per second squared, the box does not slide. However, if the truck accelerates any faster, the box slides off the back. So they're asking you to find the coefficient of static friction. So you can see here that I have my free body diagram. Gravity is straight down. The book or box would slide this way, so static friction acts upward, and then we have our normal force. And then just off to the side, I drew my triangle for breaking up gravity into its components. So I'm going to look at the sum of the forces in the x direction. Remember, I tip my axes when I'm on an incline. So my forces in the x direction on the incline are the static friction and the component of gravity down the ramp or down the hill. And so then I'm substituting in for my normal force, or for my friction, static friction. So you see the normal force. I solve for normal force over here. I plug in what I know, or I plugged in for my normal force. The mass of the box drops out, which we're not given in the problem, so that's really helpful. And then I solved for my coefficient of static friction, plugged in my values, and I get 0.521 with the values that I'm given. Of course, it's WebAssign, so you might have had different values, but the process should be the same. So hopefully this helps bring a little clarification, and if you have any other questions, let me know.